Hey, what's up, guys? Today I want to talk about recursion. If you're taking AP Computer Science A or another programming course, you have probably seen this concept before. Recursion is a very important technique in computer science, so today we will break it down step by step. Let's dive in. What is recursion? Recursion is when a method calls itself. Instead of using a traditional loop like for loop or while loop, the function repeatedly calls itself to solve a smaller version of the same problem. A recursive function essentially contains two important parts: base case, the condition that stops the recursion, and recursive call, the method that calls itself. Without the base case, the function would call itself forever, which causes an error. Now let's look at a classic example of factorial. For those of you who don't know factorial, the factorial of a number means multiplying all integers from that number down to 1. So if you had 5 factorial, it would be 5 times 4 times 3 times 2 times 1, which is 120. And here's our recursive version in Java. We know this function is recursive because we have base case, which is when if n equals 0, it returns as 1. And there's also recursive call, n times factor n minus 1. Because there's both base case and recursive call, this is recursion. Let's trace what happens when we call this function. First, when we pass in 5 as a parameter, it will first check if statement of n equals 0. Since n is not 0, n is 5, it will return n times factorial n minus 1, which is 5 times factorial 4. But we don't know factorial 4, so the program will go with n equals 4 to find factorial 4. And then it will go through this if statement of the base case, and they found that it doesn't match the base case, so it will also return n times factorial n minus 1, which is 4 times factorial 3. And then they do this for n equals 3, n equals 2, n equals 1, and then once it reaches the base case of n equals 0, it will return 1. Now the program starts calculating in backwards. When factorial is 0, it returns as 1. When factorial 1, it would be 1 times factorial 0, which is 1 times 1 equals 1. And then it would do 2 times factorial 1. 2 times 1 is 2. Then it would do 3 times factorial 2. 3 times 2 is 6. And then it would do 4 times factorial 3. 4 times 6 is 24. And then finally, 5 times factorial 4 is 5 times 24, which is 120. And this matches our answer because 5 factorial is also 120. So this program works. Now I want to go talk about advantages and disadvantages of using recursion. Some advantages are that it's a shorter and cleaner code. If we use for loop or while loop for factorial, it would take more than the amount of recursion line. So in some problems, it's much easier to write recursively. And it's also good for breaking problems down because there's base case where it's supposed to end, and there's also the call itself. And it's really help you solve big problems by reducing them into smaller versions. And it's also very useful in computer science algorithm, which might be like tree transversal or backtracking. But there's also downside as well. Downsides are that it uses more memory compared to the normal function. So each function call will store in a call stack, and it would have to take a lot of memory because it calls function and function repeatedly. Another thing is stack overflow error. If recursion goes too deep or never stops, the program crashes. This happens when the base case is not really set properly. And sometimes it's slower than loops because of the overhead of function calls. Because of repetition of function call, it would sometimes, depending on how much is the parameter, but it would make it slower to compute. And the risk of infinite recursion if you don't set base case properly. And here are common recursion patterns. First of all, the first one is string recursion. It often uses substrings, and this removes the first characters and moves the rest of the strings. And example problems that uses string recursion could be counting characters, reversing a string, removing asserting letters. Another thing, it would be integer digit recursion. It often uses n mod 10 to get the last digit and n over 10 to remove the last digit. And example problems would be sum of digits, counting digits, checking palindromes. And lastly, there's also array or arrayless recursion. It often uses index as a parameter. And example would be sum, list, index. And each recursive call moves the index forward. So arrayless recursion is another really common type for recursion. If you want to, oh yeah, and then these are a couple code that I have made before. It uses string recursion, integer digit recursion, arrayless recursion. And here are more practice if you guys want to get more hands-on. We could do sum digits, powers, Fibonacci, binary search. All these problems are really great to practice to understand recursion better. And you can also practice on coding bat, which has excellent recursion exercise. And that's a quick introduction to recursion. If you found this video helpful, make sure to like and subscribe for more videos on computer science, programming, and AP CSA topics. Thank you for watching, and I'll see you in the next video.